All right, so today we're actually starting I think I've got it spread out across 3 days, topic over quadrilaterals. Now, we've kind of briefly introduced them before. Quadrilaterals are four-sided shapes. Now, of course, we may think of some of the shapes that come to mind. We may think, oh, rectangle or a square. There's actually a lot of other unique ones out there that all fall under this blanket term of quadrilateral. And like I said, the only requirement to be considered a quadrilateral is that you have 4 sides. Now, we're going to spend, like I said, I think all 3 days this week covering different types of quadrilaterals. Today, we're covering parallelograms and rectangles. I think tomorrow are rhombi and squares. And then on Thursday, we'll cover trapezoids because they're kind of like they're quadrilaterals, but they follow their own sets of rules. Whereas, today and tomorrow, they all build, our list of information builds from one to the next. So first thing we're going to do to start off here is we're going to list 5 properties of parallelograms that are always true. If you can definitively say that the quadrilateral you are looking at is in fact a parallelogram, then these 5 things can be assumed to be true. Now, that does mean you have to be able to prove or that there is evidence that it is a parallelogram, but then we can certainly accept these. So the first one is that opposite sides are parallel, which hopefully makes sense since it is called a parallelogram. Opposite sides, so this is the number 2, are congruent. So note that it doesn't say all sides are congruent. That'll be squares, which we'll cover yesterday, is opposite sides. So one across from the other, they can always be assumed as congruent for a parallelogram. Number 3, opposite angles are congruent. Number 4, consecutive angles, which means one next to the other. So if you go from one corner immediately to one of the corners next to it, would be consecutive. So consecutive angles are supplementary. Is that my 90 or my 180? Missy, I don't know what it is, but you always get those 2 switched. Supplementary is 180 degrees, which is another reason why we use those notes so heavily. There's a lot of terms to keep track of. There's just a lot. And then number 5, diagonals, which are segments created by joining opposite angles. So diagonals bisect each other, which means cut in half. Those 5 facts, so long as you're looking at a parallelogram, those 5 facts will always be true, which then allow me to find additional information and find missing measurements and maybe set up equations to find missing values, just like we've done with shapes in the past. So I'll give you another few seconds there to jot those down because we're going to use them a lot here on this page and the next before we transition into rectangles. So the directions here leading into our practice problems is it's specifically telling me that each quadrilateral below is a parallelogram, which means those 5 rules are fair game for anything that follows. So number one, we have what looks like two sides already identified on the parallelogram and one angle. We need to find 5 other pieces of information. So I'm just going to work through the list here. AD. What is the length of AD? I'll give you a clue. Number 2, opposite sides are congruent. What is opposite of AD?
BC.
BC. How long is BC?
8.
8. So AD is also 8. What about DC? It's opposite of
AB would be 15.
opposite of AB, which is 15. So they are both going to be 15. Next, we have the measure of angle A. Now, we only have angle D. How would you describe the relationship between A and D? Are they opposite or are they consecutive?
Consecutive.
They are consecutive, and consecutive angles are supplementary. So how would you figure out A?
180 minus 68.
180 minus 68, which gives you, I believe, 112.
Yes.
Okay. Measure of angle B would be 68. There's 2 ways we could say that B is consecutive with A, or we could just say B and D are opposite, in which case number 3 says opposite angles are congruent. So it would be 68 as well. And then angle C?
Could you minus 180 from 112?
So you could do that. That would give you angle B, but angle C is opposite angle A, which means angle A and C are congruent. So that'd be another 112 degrees. Yep. So it's just about working our way through. Look at what we have, look what information we have, and then just piecing together what we can then find. Number 2, almost identical in terms of style. All they did was change some of the letters, rotate it, change some of the measurements. So for the sake of making sure we have plenty of time today, I'm going to give you these answers. Later on, if you have some questions, just let me know. JK is going to have a measure of 21. KL is going to be 29. The measure of angle J should be 127 degrees. Angle K should be 53 degrees. And angle M should also be 53 degrees. Jumping down to number 3, slightly different information being presented to us. We have another parallelogram. This time, though, there are also the diagonals of this parallelogram drawn in here, which kind of gives us some more pieces to consider. And it's giving me some information here. First off, it tells me that RT is 30 units, or yeah, a length of 30, which is right in there if you need a visual aid to see where that's located. And then we have 2 of the sides of the parallelogram, 27 and 18. Doesn't look like we're finding any angles on this one, which is nice. So what would be the length of UT?
Would it be 27?
It would be 27 because it is opposite of RS. What about ST?
Is it 18?
It would be 18 because it is opposite of RU. Then we get a little sneakier. VS. Just a clue, we have moved into the diagonals. What'd you say, Jonathan?
7.
How'd you come up with 7?
That's the line right there. UV.
UV is measured as 7, but how does that tell me that VS is 7?
Because you can see that it's the middle line between the 2
Uh-huh.
lines is between is connecting the two angles.
Okay, which means it's a diagonal. And number 5 up above says that diagonals actually bisect each other. So that means that they are two halves. So UV and VS are congruent. So one of them 7, that means both of them are 7. VT, this one's a little bit sneakier. We know the entire length of diagonal RT, but we are looking for just part of it. But if we go off with the same clue, oops, wrong tool. If diagonals bisect each other, then that means that these are two equal halves as well. Well, if the whole thing is 30,
I think 60.
oh, careful,
50.
it's cut in half.
Oh, it would be,
It'd be 15.
yes.
Yeah, so the whole thing's already 30. If it's being bisected, the two halves then would be equal halves of 15. Good. Number 4, similar diagram. This time, though, we're really looking in at the angles. So some work to kind of keep our heads, on track here. Looks like we have some angles squeezed in. We also have the measure of angle FED, which is this entire angle down here is 134 degrees, provided from the information beneath it. So let's see. Well, let's think. We need to be sneaky. This one, I actually want to use number 1 to help me out. That opposite sides are parallel. So what I'm going to do here is I'm going to sketch in these little arrows here, which was one of our ways that we used to show parallel sets of sides. So those two segments are parallel. And then separately, so I do a double arrow here. These two sides are parallel. And as a result, if you think about it, the diagonals then also behave like transversals, which means we open up a whole new list of options dealing with alternate interior angles and things like that. So on this one, let's see, we're looking for the measure of angle DEC, which is right here. Do we have enough information for that right now?
No.
Ooh, this one's sneaky. I know the measure of the whole angle, FED. I know part of it's 71. To find the remaining, I would just need to do 134 minus 71, which gives me, I believe, 63. So again, the whole angle, this big angle here on the bottom angle is 134 degrees. We know part of it is 71. The other part then is just whatever is remaining, 63 degrees. Next up, we have measure of angle CDE. CDE is right here. That is this full angle over here, ignoring the diagonal. Well, if I think about it, isn't angle E of our parallelogram and angle D of our parallelogram, aren't they consecutive?
Mhm.
If I know the whole thing is 134 here, what does that leave me with out of the 180? 46. So 180 minus 134, you said 46.
Mhm.
All right. Next up on our list, we have angle ECD. Now this one's rather sly because at this point, there's so much information going on here. But if I were to ignore parts of it, hopefully I could spot that this angle right down here at 71 degrees and this angle right here
For the same.
are the same because they are alternate interior angles. So that one would be 71 degrees. And then the last one, angle DFE. Let's see, where is that at? DFE. Okay. Well, DFE, this one's going to be a bit of a process because I'm looking for this information right in here. Well, I know part of that split angle is 21 degrees. Do I know what this whole angle is down here in corner F?
No.
Ooh, but I technically do because F is opposite D, and opposite angles are congruent. So this entire angle is 46 degrees. The angle we're looking for is the piece that we're missing. We already know 21 degrees of it. So what's left over for our angle?
Okay.
25. I would say the hardest part today is probably going to be just keeping track of the sheer amount of numbers that are floating around inside of here. Odds are, though, if you kind of work your way through the list, there's some information somewhere that'll help you find what you're looking for. I'm going to do number 5, and then I'll give you the answers to number 6 if you want to try that one on your own. Because again, I want to make sure we have enough time to get through our notes today. This one, a little bit different because it's given me the information in a list up above. Our diagram's about to get really crowded though, as we try to work our way through it. So on this one, XY, which is here on the right, is 15. WX, which is this other side, is 22. ZX, which is, how am I going to do this one here? It's not really a good way to do this one. Yeah, I'll do it this way. ZX, which goes through here, is 52. WT, which is this little segment inside part of the diagonal, is 23. Measure of angle WZY, which is this whole angle over here in the bottom left corner, is 72 degrees. WXT, which is right in here, is 35 degrees. And ZWT is 59 degrees. ZWT. So what a mess. Just because there's so many measurements going on in this one. But I've kind of got them visually on there, so hopefully we can start to work through this process. Starting with these segments. So ZW, what is the length of ZW?
15,
15. How's it 15?
because it's opposite from YX.
Yep, it's opposite from YX. Opposite sides are congruent. What about ZY?
It's opposite side from 22.
Yep, it's opposite the side measuring at 22, so it's also 22. What about TX?
Be half of 52.
It would be half of 52. That is correct, which I believe is 26.
Yeah, it's 26.
And that's because that diagonal is being bisected by the other, which while we're talking about that, that must mean that this other diagonal is also being bisected into two halves. So WY, which is the entire second diagonal, is going to be what?
Would it be 46?
It would be, because we have WT, which is just one of the halves. If both halves are congruent, we just double that for the whole thing. So we get 46. So that takes care of the sides. So what I think I'm actually going to do here real quick is clean up my diagram. You don't have to do this on yours if you don't want to, but I'm going to get rid of all the side information. So that I can really just focus in on my angles now. Of course, this will be the most useful in the video because you can rewind and fast forward as necessary, but now at least I have less distractions in there than what I started with. So let's see, angle TZY. So TZY is down here in this corner, which if I look at it, this one's kind of sneaky, but it is opposite, or excuse me, alternate interior from this angle right here. Careful. Opposite or alternate interior from this angle up above. So it would be 35. Next up, we're looking at XYZ. So XYZ is this entire angle over here. Well, I'm in luck because technically I'm looking at corner Y. I know its consecutive angle here at corner Z is 72. Consecutive angles are always supplementary.
180 minus 72.
So I take 180 minus 72. I believe equals 108. Next on our list is angle XWT, which is right up here, XWT. Well, here's where I need to get a little bit sneaky because I happen to know that angle Y and W on our parallelogram, ignoring the diagonals, are opposite. So that means that whole angle over there is 108. But I know part of it already, which is the 59. If you remove that out of the total, what does that leave you with for XWT? Whoa.
$49.
49. And then last but not least, angle XYT, which is, let's see, this angle right here. Well, I want to change my color here on my pen. So XYT is opposite, or excuse me, alternate interior of this 59-degree angle over here on the other side. So that means that if it's an alternate interior, it will also be 59 degrees. So mathematically, if you're thinking about numbers and crunching numbers and calculations and things like that, there's not a whole lot to calculate, but because of the sheer amount of measurements that are in here, it is going to be pretty easy to get some of those values mixed up. Now, again, like I said, for the sake of time, I'm going to give you the answers for the next one, which looks like it's purely focused on the angles. So probably a lot of alternate interior angles and things like that. Let's see here. Screen. So starting in the left-hand column here, angle GFJ is going to be 56 degrees. FGH is going to be 124 degrees. HFJ is going to be 34 degrees. HKJ is going to be 101 degrees. JGH is going to be 67 degrees. FGJ is going to be 57 degrees. FHJ is 22 degrees. And GJF is going to be 67 degrees. Now, again, it's just a process of going through and very carefully working your way through the angles that you have, always remembering what it is you've already found, because sometimes those values will help you with later measurements. All right. So then we get to the back side here, and here's where we start to throw in a little bit of that algebra, along with these specific relationships we've set up. Forcing us to find, set up an equation to then find the missing value. So for number 7, it's asking us to solve for x. What could I set up here in order to do so?
What do you mean 9x minus 25 equals 5x plus 7?
9x minus 25 equals 5x plus 7. Why could we set up that relationship?
Because they're congruent.
They are congruent, and I'm assuming that's because they are opposite sides. Is that correct?
Yes.
So if they're congruent, they must therefore equal each other. So 9x minus 25 must equal 5x plus 7. Then it's just a matter of solve.
Subtract 5 both sides.
Yep. Subtracting that 5x from both sides to get it to one side. Leaves me with 4x minus 25 equals 7.
And 25 to both sides.
Yep. Add 25 to both sides. So I get 4x equals 32.
Divide by 4.
Divide both sides by 4.
Eight.
I get x equals 8. Number 8, exact same setup. Be careful though, the instructions are a little bit different here. It's actually asking you to find the length of side YZ.
You gotta go a step further.
You just have to take it one step further. So I'm just going to give you the answer here on this one. Let you work that one out if you so desire. YZ on this one should end up equaling a length of 45. Now, if you'd like a little extra help, you should get an x of 4 in the process of solving it. That 4, though, is what you'll use to help find YZ. Number 9, a little bit different here. It is asking us to solve for x, but now we've thrown in some diagonals into the mix. This is telling me that TV, which appears to be an entire diagonal, is 74. WV, which appears to be part of the diagonal, is 4x plus 1. Okay. Well, what do we know about the diagonals in a parallelogram?
You bisect them.
They bisect each other, which means TW and WV are congruent to each other, which means how many 4x plus 1s are actually in that entire diagonal? There's 2 of them. So take 2 of WV because they're congruent anyways. So 2 times 4x plus 1 should equal the total length of 74. Well, then we just go into solving mode. I'm going to distribute my 2 here to get 8x plus 2 equals 74, and then I just solve. Subtract 2 from both sides. I get 8x equals 72. Divide both sides by 8,
X equals 9.
and x equals 9. Number 10 is very similar to that one, except this time it's asking you to find NQ, which is the entire diagonal here. But similar fact that we're going to use here is that the diagonals do in fact bisect each other, which is convenient because it gave me NS as 2x plus 7 and SQ as 5x minus 23. What am I going to do with those two expressions?
We do 2x plus 7 equals 5x minus 23.
Perfect. You set them equal to each other. For the sake of time though, because it's very similar to the previous one, I will give you the result here. It does mean you have to find x first because it is asking you to find NQ. But once you see it all the way through, NQ should be 54. Now, quick suggestion, or not suggestion, hint. You should end up getting x equals 10, which is what allows you to find the 54. Number 11, switching gears here a little bit, now looking at angles in the parallelogram. Here we have angles A and C. We have expressions for each. What equation can we set up for these? I'll give you a clue. Angle A and C are opposite angles, which immediately tells me that they are congruent. That would mean angle A equals angle C, and we have expressions for each. So we should be able to write 6x minus 15 equals 4x plus 11. Subtract 4x from both sides first. Two 2x minus 15 equals 11. Add 15 to both sides. Gives me 2x equals 26. Divide both sides by 2.
13.
Get x equals 13. But be careful.
Right, you gotta plug it into that x.
Good. So x is not what we're actually looking for on this one. We need to find the measure of angle B. Well, that's kind of rude because angle B we had no information of. But that's okay, because if I can find either angle A or C, it's going to help me find angle B. So it's up to you. Would you rather plug it in for the expression for A or the expression for C?
C.
C. Okay. So off to the side here, angle C equals 4 times our x, which is 13, plus 11.
63.
63. Is that the full answer?
Yes.
Oh, so you already calculated it. Angle C equals 63 degrees. Now be careful though. I need angle B. So, Ollie, you were saying,
Would be 63 minus 180.
That's what I was gonna add.
technically the reverse.
Yeah, I was just gonna add.
Well, I wouldn't want
We
to.
already added together there, I guess.
I wouldn't want to add angle C and A together because that doesn't quite get me to angle B, but angle B and C are consecutive. And I forget which number it was on the front. Number 4, consecutive angles are supplementary, which means if I took 180 minus angle C, which is 63, I get that angle B, I believe, is 117. Now, the picky part of my brain is saying, technically, I need to put a dashed line around 16 because, or around X equals 13. That technically wasn't what we were looking for, but we needed it to find where we were headed. All right. Number 12, similar setup. Have you work those angles. This time, though, they're not opposite. They are consecutive. So instead of setting them equal to each other, they should add to equal 180. So I would set this one up to say 3x plus 5 plus 8x minus 12 equals 180. Combine my like terms. 11x minus 7 equals 180. Solving it from there, add 7 to both sides. I get 11x equals 187. Divide both sides by 11. I get x equals 17. Make sure you read the instructions. X, it was just something I was missing. It's going to help me find what I'm actually looking for, which is angle R. Now I paused for a moment and I realized, well, angle R, I know nothing about. However, I do know angles P and R are opposite each other, which means they are congruent. So whatever angle P is will equal angle R. So theoretically, if I know the measure of angle P, do I also know the measure of angle R? Sure. So angle P, we have an expression for 3 times x, which is 17, plus 5, 56. And you calculate that all out. And if angle P is 56 degrees, angle R is also 56 degrees. Good. Number 13, I'll do 13, we'll skip 14. Number 13 tells me angle KLH, which is this big angle down here on the bottom right corner, is 134 degrees. Solve for x. Well, this one's kind of sly because JHN, which is this 25-degree angle, is an alternate interior with angle LKN, which means this is a 25-degree angle over here as well. Now, what that means then is because of this information here giving me all of what would have been angle K, and I'm looking for, in a manner of speaking, well, actually I have technically angle L if I'm ignoring the diagonals, as 134. These are consecutive angles, aren't they? Consecutive angles are always supplementary, which means if I add this whole angle, which are these parts, plus this whole angle, which is 134, it should equal 180. So 4x plus 9 plus the 25 degrees that we moved over there because they are alternate interior angles. That is essentially, we'll call it angle K of the parallelogram, plus angle KLH, which is essentially angle L of our parallelogram, is 134. And since they are consecutive, they should equal a total of 180. Well, if I combine like terms, 9, 25, and 134, 168. So I get 4x plus 168 equals 180. Subtract 168 from both sides. I get 4x equals 12, I believe. Divide both sides by 4. X equals 3. Which was what I was looking for. All right, number 14, similar. It does give you measure angle ABC, which is this big angle up here in the top left corner. And it gave you part of ABC, which is ABE. But I'll give you a clue. This angle down here, the 6x minus 11, is an alternate interior angle with the one up here at the top. Now, I'm not going to solve this one all the way through, but I will give you something to get started, and I will give you the answer. If you have both parts of that big angle, and you know the overall measure of that big angle, that must mean then that the 4x plus 6, which is part of it, plus the 6x minus 11, which I know is that other part of that big angle there at the top, since they're alternate interiors, should equal the whole angle of 115. Now, be careful on this one because it is asking for the measure of angle ADB, which is the 6x minus 11. But as you work through it, you should end up getting that the angle ADB equals 61 degrees. Now that is in part because you should get that x equals 12. So a lot of angles, especially when you throw in those diagonals to kind of keep track of, but not a whole lot of different new vocabulary. We're still using things like consecutive. Consecutive angles are always supplementary. Diagonals, those are a little bit new, but they bisect, which means cut in half. But then we use a lot of either congruent or supplementary to work us through this process. Now, it's important we don't forget that information because if you take a look at the next page, properties of rectangles, right there at the top, you'll notice they have the same properties of parallelograms. So those 5 things we listed just moments ago are relisted there because they also apply to rectangles. Because rectangles are actually just special types of parallelograms. Now, because they are special, they come with 2 new things that we can also assume to be true, so long as we know they are rectangles. And that is one, that all 4 angles are right angles. which means they are measured as what? 90 degrees, yep. And 2, not only now do the diagonals bisect each other as they did in parallelograms, the diagonals in a rectangle are congruent. Now, these 2 bonus ones here that we just wrote in do not apply to parallelograms. It works one way, it does not work backwards. Has to be a rectangle for these 2 extras to apply. Using that information, however, we should be able to work through some of this process rather quickly with a little bit of maybe extra help. We'll see. So number 1, looks like we're given 2 of the sides of this rectangle, and we have some diagonals thrown in there as well. What is side QR? 10, because it's opposite PS. What about SR?
24.
24. SQ? We'll come back to that one. PR? Well, we'll have to come back to that one. And QT. So we really need to find SQ. And to do that, I have a little highlighting tool here. I would like to look at this portion of the rectangle, because if you recall, all the angles in a rectangle measure 90 degrees, which means if I were to imagine this kind of green highlighted triangle I have in there, that is a right triangle for which I have 2 of the legs. I am missing its hypotenuse, for which I can use the Pythagorean theorem from, because I told you triangles still find a way to sneak their way back into these lessons. So this is to find SQ. I'm using the Pythagorean theorem. So the leg, so I'm going to say 10 squared plus the other leg squared, so 24 squared equals, I'm going to use X for SQ here, so I can then go through the process of solving it. 10 squared is 100, I know that one. What's 24 squared? It's like 480.
576.
Shoot, 576. I was way off. Is it? 24 squared is 576. Well, I'm gonna believe you until someone proves me wrong. Or proves us wrong, I guess, in that case. 100 plus 576 gives me 676. And then how do I get that X by itself? I get rid of the square. Yep.
Square root.
Yep, Tier, you got it. Ollie, you're making the gesture. We're going to take the square root of both sides. Which then I'm going to flip it around here as well. X is approximately, or actually, is it exact?
Yeah, exact. 26.
Exactly 26. So again, this was my side SQ. So SQ over here is 26. That's nice. What's PR then? The other diagonal.
The same.
It is the same because in a rectangle, not only do the diagonals bisect each other, they are congruent. So it is also 26. And then QT, which is only half of SQ, whoops, I ruined it. It would be 13 because since it's a special form of a parallelogram, that diagonal is being bisected. Okay. Number two, very similar. So I'm going to give you those answers. Where they gave you measurements are a little bit different, but work your way through that list. You should be able to find them. But here's the information you can use to check. AC should be 30. BD should be 30. BE should be 15. AB should be 27. And BC, I believe this was rounding if I recall, should be around 13.1. So decimal there is fair game. If I recall, I believe it had something to do with the Pythagorean theorem. The odds of you taking a square root and it coming out as a perfect number is low, which is why decimals is certainly plausible. Number three, this time focusing on the angles. We have one of our angles in there, so we're going to work our way through there. First one it's asking us for is for angle MJK, which is this upper left corner of our rectangle. What is the measure of angle MJK? Gave you a clue. I said it was the upper corner of a rectangle.
90 degrees.
It'd be 90 degrees. MJL, okay, well, that's this part right here, this segment of the 90 degrees that we were just looking at. I know where 27 of those degrees are. If you take that out of the 90, what's left? 63 degrees. Okay. Next up on our list is JLK. JLK. Well, this one's kind of sly, but remember, rectangles are just fancy parallelograms, which means this angle right here and this angle down here are alternate interior angles. 90 subtract the 27. Yep, which we've already done. So that's 63. KML. Well, KML. Just right here. So this one. Try and decide the best approach here. Oh. Any ideas on this one? For KML.
Would it be 27?
It would be. Can you tell me how you came up with that?
Because it's like the opposite interior of the other one, of J. Is that right? I don't know. If that's right.
Well, KM, so these don't specifically relate to each other that way because they aren't sharing the same diagonal, which would in this case be the transversal. But check this out. The diagonals are congruent, right? And they bisect each other, which means that this half equals this half, which equals this half, which equals this half. Which means technically then, if I also think about it, this side is opposite this side, which makes them congruent. Whether I realize it or not, this triangle right here and this triangle right here, are they not congruent?
Yes.
Which means if they are congruent and they're isosceles for that matter, it would in fact be 27 degrees. And then MNL. Well, going off of that information we had here, if this is 27 degrees and this is 27 degrees because it's isosceles, what do all the angles in that little orange triangle at the bottom add up to? 180. So we know we need 180. Take away the 27 from one angle plus another 20, excuse me, and another 27 from the congruent angle should give me a total of, I believe, someone please check me on this, 126.
That's correct.
So I know I said we moved on from triangles, and I think I specifically said we're moving on from learning new things about triangles. Triangles will still find their way into these problems though, because a lot of times when you cut up a shape, normally you get triangles. All right, number 4, very similar, but for the sake of time, I'm going to give you these answers here. Measure of angle XWY should be 58 degrees. YXZ should be 32 degrees. WVZ should be 116 degrees. XWZ should be 90 degrees. And XZY should be 58 degrees. So vocabulary that is still going to creep its way in here. Alternate interior angles already have shown its face. I've now talked about congruent triangles, isosceles triangles, vertical angles may pop up from time to time. All sorts of things that could still show up from previous units. Last one, again, very similar, kind of a hybrid of the previous 4 problems, having you find some sides and some angles. But again, I want to get to the last page in our notes today. So I'm going to give you the responses here. AC, try to fit it on my screen nicely. AC should be 42. EB should be 21. BC should be 26. AB should be 33. The measure of angle ADC should be 90 degrees. Angle ABD should be 38 degrees. Angle BCA should be 52 degrees. And DEC should be 104 degrees. Again, there would be a little bit of work involved. There is a Pythagorean theorem in there that you would use. Some of those things may be supplementary, so maybe subtracting someone from 180, but it really depends on where you start and how you work your way through it. Like I said, I wanted to make sure we had a little bit of time to work on this back. While on that note, I will tell you, if it feels like we're going a little bit fast today, we're going to offset it tomorrow. Tomorrow's notes are half as long. So we'll have time to kind of still continue processing today's information and the new information I introduced tomorrow, which actually builds right off of where we end today. So you will get time to digest this information. All right. Number 6. This is very similar to our parallelogram page. Find EF. And I've been given expressions of 2 sides. What could I set up here?
They're equal to each other.
They are equal to each other because they are opposite sides. And opposite sides in parallelograms, therefore also rectangles, are congruent. So 7x minus 39 must equal 3x plus 5. Going through the process of solving here, I'm going to subtract 3x from both sides. So make 4x. Minus 39 equals 5. Add 39 to both sides. I get 4x equals 44. Divide both sides by 4. X equals 11. But it's not what I'm looking for. I want EF, which conveniently, that is where one of my expressions are at. So 7 times x, x is now 11, minus 39. So that's what, 77 minus 39, which I believe should be 38. Next one, I'll give you the answer to. Similar setup, this time focusing on the diagonals. Make sure you pay careful attention though. It is asking you to find VT once you find your X. VT on this one shouldn't end up being 13. Notice VT is only half of a diagonal there. So it may help to find that diagonal it exists with. Divide it by 2. Hint, hint. I wanted to make sure we had enough time to get to number 8. And well, some of the later ones too, but we're making good progress. Number 8 says if JM equals x plus 17, which is part of a diagonal, and MK, which is a part of the other diagonal, is 5x minus 23, find JL, which is a full diagonal. Well, something special by diagonals in rectangles, and we've kind of already used it in an earlier example, but 2 things are said about diagonals in the rectangle. One, because they are parallelograms, they bisect each other. And 2, because they are rectangles, they are congruent to each other. So if you bisect the same number twice, if you bisect a number, it's always going to give you the same 2 halves, which means all the diagonals, since they are all congruent, each of their halves are also all congruent, which means JM and MK are congruent, which allows me to write the expression that x plus 17 equals 5x minus 23. So I would subtract x from both sides. Gives me 17 equals 4x minus 23. Add 23 to both sides. I get 40 equals 4x. Divide both sides by 4. I get, I'll flip it around here as well, that x equals 10. But be careful, that's not actually what we're looking for. It just helps me get there. I need to find the measure of JL. Well,
20,
sorry,
maybe 20.
careful. X is not a measure of anything up there. It's just merely a part of the expressions we're given. But I like where your head's at. You are thinking doubling, but I wouldn't double X. I could, however, double JM, which means I need to know JM. So JM equals x, which is 10, plus 17, which equals 27. JL is twice as long, so 2 times 27 gives me 54. Number 9, similar situation. You're looking for WT. If you try this one on your own, you should get that WT equals 34. Number 10, find the measure of angle BCE, which isn't even labeled here, but if I can find what X is, odds are it'll probably help. And what I've been given right now are 2 expressions. If you look carefully though, these are alternate interior angles, which means they should be congruent. So that means that the 11x minus 3 should equal the 7x plus 5. Solving it here, I would subtract 7x from both sides. Get 4x minus 3 equals 5. Add 3 to both sides. I get 4x equals 8. Divide both sides by 4. I get x equals 2. Now, I'm not looking for x, but I can use it. I am looking for the measure of angle BCE, which is right here in this section. Now, what do I know that this whole angle would be for that corner of the rectangle?
X minus 3.
It should be 90, I heard someone say. Yeah, probably. I know 11x minus 3 makes up part of it. And now that I know x, I can figure out that exact measurement. And once I know that exact measurement, take it out of 90, you got what's left for the piece we're looking for over there. So I first need to figure out angle DCE, which is where the 11x minus 3 is. Plugging in my value, I get 11 times 2 minus 3. Which is what, 22 minus 3, 19?
Yeah. And 90 minus 19 is 71.
Mhm. So angle BCE is 90 minus the 19, and you said 71? Okay. Next one, I'm going to help you set it up, and then I'll give you the answer. Notice that this time they gave me expressions for 2 parts in the same corner of the rectangle. Well, what do I know that that total angle should be?
180. I
Mm,
mean, sorry, 90.
in the corner of a rectangle, it should be 90, which means if you were to set this one up, 3x plus 2 plus the 12x minus 17 should end up equaling 90 degrees. Now, if you see that one all the way through, you should get that x equals 7, which if you read the prompt carefully, though, that's not what you're looking for. With a little bit of work, you should end up getting that angle JHI equals 23 degrees. Number 12, very similar to number 11. This one's kind of sneaky because if you think about it, this angle where the 5x minus 8 is an alternate interior angle over here at WZR, which means that this one is just 5x minus 8 as well. So very similar to the last one, those two should add together to equal 90 because that is a corner in the rectangle. So you're going to have a very similar setup. Going through that process, you should get that x equals 13. But be mindful of what it's asking you to search for. You're looking for the angle XZW, which with a little bit of work you should get is 57 degrees. And then the last one, we're going to see it all the way through just because it's a little bit more intense in terms of how many different skills it takes us or bits of information it requires us to recall. Number 13, luckily it is just asking us to find x, but notice that it is giving me this angle in here, which isn't even related to this one over here on the left. There's a lot of information going on in there, at which point I would like to say, you know what? I'm going to go into triangle mode and think if I can work out something about this triangle here, I could probably figure out something about that x. Well, as I dig a little deeper, we know that all the segments of the diagonals, because they're not only being bisected, but are also congruent, means all those segments are congruent, which means this is an isosceles triangle. Meaning 5x plus 7 is same with this 5x plus 7 here. But then that still leaves me with a piece of information because I'm going about it thinking, well, I know all those angles should add up to equal, I'm thinking triangle 180. I know that two of those angles are 5x plus 7s. How could I figure out this missing angle right in here at DHG?
2 times 5x plus 7 equals 180.
Not quite, because that's only two of the angles. Triangles have 3 angles. I need that missing angle first before I can set it equal to 180.
180 minus 134.
180 minus 134, because these are a linear pair, which I believe gives you 46. Then we could say 2 times the 5x plus 7, because there are 2 of those in there, being an isosceles triangle, plus the 46-degree angle should equal a total of 180 degrees, because we're focused on just that little triangle inside that rectangle. Well, it's a little bit of elbow grease. We should be able to work our way through, and we'll be in luck because we're just finding x anyways. Distribute first.
Did you freeze?
Did I? Oh, shoot. Of course it would freeze on the last problem. Okay, so we're back there. 2 times the 5x plus 7s, because we have those 2 angles that are the same, plus the 46-degree angle, which is all three angles now, should equal 180. I'm working on solving this equation. I'm first going to distribute the 2 to get 10x plus 14. Bring down the 46, the equals, and the 180. Combine like terms. 10x equals 60. Subtract 60 from both sides. I get 10x equals 120. Divide both sides by 10. I get x equals 12. Which fortunately for our last one here, that's all it was asking for. So a couple quick comments. The hardest part is going to be just letting your eyes adjust and find those angles, find those segments, find those sides. But as long as you know what shape you're looking at, you at least then know at least 5, or in the rectangle's case, 7 things to be true. Rely very heavily on those bits of information.